Hi all, welcome to my YouTube channel, Know About Embedded System. In today's video, we're going to explore more about one important protocol that is called as I2C. I2C stands for Inter-Integrated Circuit, and one of the powerful and more popular, and most of the industries are using this protocol, Inter-Integrated Circuit. So in this today's video, we will understand how I2C protocol works. So before starting the video, if you are a new viewer to my channel, kindly subscribe my channel and get notified when we upload a new video and gain the knowledge of embedded system. So let us start the video here. I2C stands for Inter. I told you it's yeah, I2C is a very popular protocol, as I told you already. Why? Because of many reasons. One by one we will see here, and these are all the important features of your I2C protocol. I2C protocol popular because of it will support multiple masters. The important thing is I2C will support multiple masters. Here you can see we have master 1, master 2. So it will support multiple masters, and at the same time it will support multiple slaves as well. So these are all the major reasons, but there are some more reasons are that we will explore now. See, basically, the I2C is a multiple master and multiple slave. This is what I told you already. So multiple slaves and multiple masters you can connect to the I2C bus. And second thing is it's a serial communication, obviously, and it is a synchronous communication. So we use serial and synchronous communication, and it is a half duplex communication, and uses two wires. I2C will use two wires. So this is a very important thing, and we will call those two as SDA and SCL. SDA stands for serial data, SCL stands for serial clock. Here you can see we have two lines, which is one is called as SDA and one is called SCL. SDA stands for data, SCL called as clock. Okay, and operating speed 100 to 400 kbps. This is a standard speed of your I2C communication, 100 kilobits per second and 400 kilobits per second. This is a normal speed, and in I2C also different operating modes are there, like ultra speed mode and high speed mode and ultra high speed mode. In that, I2C will operate up to 1 Mbps as well. Okay, so the speed is like this, and I2C basically address based communication. It is address based communication, and it uses 7-bit address, and it is possible to connect up to 128 slaves. This is a very big thing about I2C. I2C will use address for each slave. That means I2C will use a 7-bit address for each slave to communicate, and if we calculate 2 power 7, so 128. So that means 128 different possibilities you can generate, and 128 different slaves you can connect to the I2C bus theoretically. Okay, this is a big advantage of your I2C. And then it supports arbitration and clock stretching. What is this? I'll explain later. And so arbitration means it is a multiple masters that I'll explain later. It is used to connect a low-speed communication devices. I2C is designed to connect with a low-speed communication devices like your LCD or your memory unit, or maybe even microcontroller which is running in a low speed. So in such situations, we will use I2C. Short distance communication, less than 1 meter or less than 50 centimeter, we will use this I2C protocol. And it is a byte oriented protocol. So every time we will transmit one byte at a time, and it uses an acknowledgement for every successful and every failure transmission will have an acknowledgement here, and it will also have one frame to transmit a data. So these are all important points for your I2C. In the interview, if anyone asks about the I2C protocol, please explain these points, and that will be more than enough. What do you know about I2C? Explain these points and explain I2C working principle. That is more than enough answer uh, to answer in the interview. Okay, let us go to the I2C working procedure. So how I2C will work? So already I told you guys, I2C is one of the standard and one of the very high-end protocol compared to any other UART SPI or any other protocol. Okay, so we will understand how it works. So already I told you the I2C is I2C is a multiple masters and multiple slave communication protocol. It will support both multiple masters you can connect and multiple slaves also you can connect. And I2C is just two wires, as I told you. One is SDA and one is SCL. Here you can see I have given the expansion for the SDA and SCL. SDA stands for serial data and SCL stands for serial clock. So we have two wires, and here you can see the clock will be supplied from the master. Always do remember, most of the controlling information, controlling most of the time, master will control the complete operation of your I2C. Master will generate the clock and master will also transmit data and master will also receive the data. But complete controlling will be taken care by master. How the communication will happen. And before that, you should understand how the circuit is designed. So your masters, if you have multiple masters and multiple slaves, everything should be connected to the common bus that is called as SD and SCL. So how many slaves you have, how many masters you have, everything should be connected to common line that is SD and SCL. And these two common lines are open drain concept, and these two SD and SCL lines, on another hand, these two SD and SCL lines are connected to VCC supply along with the pull-up resistors. So here we're using pull-up resistor to control the current and also to control the speed of the communication as well. Okay, and if you want to start a communication, the any one of the master 1 and master 2, any one of the master should start the communication by sending the start condition. So master will start the communication by sending the start condition, and once start condition is sent, followed by slave address. To which slave you want to communicate? Do remember here, it is not possible to communicate between two different masters. In I2C, master to master communication is not possible. There is no communication between two masters in the I2C. Very clearly, I'm telling there is no communication in the in the I2C between two masters. Always communication should happen from master to slave or slave to master. So coming to the topic here, start condition, slave address, and if to which slave you want to communicate. Say for example, master 1 wants to communicate to the slave 1. Here you can see I already told you each slave will have its own address. In the previous slide I have already explained. Each slave will have its own address, that is a 8-bit address. Actually it's not a 8-bit address, we will have 7-bit slave address. Every slave will have its own unique address. So whenever your master wants to communicate, master should send the starting address followed by slave address. If you want to communicate with the slave 1, you should send the address as 10, 0x10, and followed by read write bit. Read write bit. So this read write bit will indicate whether data wants to transmit or whether you want to receive the data. Read write bit will tell you whether you want to transmit data or receive the data. Okay, so like that, master will transmit address followed by read write byte, and upon reception of slave address, for example, let us assume I have transmitted 0x10. So once if transmit a 0x10, this 10 will be transmitted to all the slaves, slave 1, slave 2, and slave 3. So your respective slave will compare your slave address. Transmitted slave address is 10, and they will compare, slaves will compare the address 10. So here it is 20. The slave 2 will be, it's going to ignore. Slave 2 will ignore because address is 20 here. Slave 3 will compare. So 10 with 30. So this is also not matching. So obviously slave 3 also will be neglected. So with respect to the slave 1, the address which is sent by the master is 10 and master slave address is also 10. So then the slave will send one acknowledgement saying, and it will indicate its presence. It will send one acknowledgement by sending 0. The slave 1 will send a 0, that is called as an acknowledgement bit here. Okay, indicating that the slave is present. So once the confirmation, after getting the confirmation from the slave, so master will either master will transmit data to slave or slave also can transmit data to the master. Continuously the communication will happen, and finally if your master wants to end the communication, the master has to send one stop condition. So once the stop condition is sent by the master, the communication will be halted, and I2C bus will be released for second master. So this is how I2C communication will work in the embedded communication. If we explain this much in the interview, that is more than enough. Okay, I hope this is clear to all. Now let us move to the next topic, I2C frame. I already told in the introduction slide, feature slide, I2C will have its own frame. I2C is protocol, I2C protocol basically it is frame-based communication protocol, and it is having its own different fields, and we will understand one by one. This is also one of the important topic with respect to the interview. In the most of the interview, you will get a questions how I2C frame is designed. Can you explain I2C frame? Like this, you'll get a question. The first point, yeah, so this is a I2C frame. We will have a different fields here. I2C start bit is there, slave address is there, read write bit, acknowledgement, data, acknowledgement, data, acknowledgement, data, and it goes on. And finally, you have to stop the communication. This is a very simple I2C frame, very easy to remember, and we will understand its each fields. The start condition. The first one is start condition. Who will initiate the start condition? Start condition will be initiated by the master before starting any data. And this start condition always will be an active low signal by sending 0. Master will send a 0 or active low signal as a start of communication. Second thing, address. Address field, or it's also called as slave address. I just now have explained address is nothing but slave address. The master will send to the I2C bus. In the slave address field, it will send a 7-bit or 10-bit slave address to which slave you want to transmit a data or you want to receive. So that the address will be specified in the form of address field. So for example, I told you already 0x10. This is one slave address, right? And then I already told one more thing, like I2C, it is possible two different slave address. One is 7-bit. So when you go for 7-bit, it is possible 128 slave address. And when you go with a 10-bit addressing, when you go with a 10-bit addressing, it is going to generate 1024 slave address. This is the beauty of our I2C protocol. In I2C, it is possible to generate two types of slave address. One is 7-bit and one is 10-bit. In 7-bit, when we go, it is possible to generate 128 different slave address. And when we go with a 10-bit slave address, it is possible to design up to 1024 slave addresses. That means we can connect up to 1024 slaves. That is the theoretical meaning here. Okay, so because of this, I2C is more popular. You can connect more devices. Okay, the next point, read-write bit. Yeah, I forgotten to explain read-write. So this read-write is there. This will indicate whether you want to read or write. So when you see read-write is equal to 0, you're going to write the data. Write, or you can say send the data. Okay. And when you keep RW is equal to 1, read the data, or you can say receive. So what is the meaning of read-write? Read-write will indicate whether master wants to read a data or master wants to write a data. So this is a single bit here, read-write. 0 means write, or you can say signed. And when you say it is 1, it is going to read, or you are going to receive a data. So that is the meaning of read-write. Next, acknowledgement field. So acknowledgement field already I have explained. Once the slave address and read-write bit both are sent, both together it is 8-bit, 7-bit address and 1-bit read-write bit. So both together it is 8-bit. So once your slave is received with a 7-bit slave address and read-write bit, slave will give an acknowledgement here. Slave will give an acknowledgement to the master by sending again active low bit. It is going to, slave will send an active low bit to the master to indicate it is present in the I2C circuit. Okay, that is called as an acknowledgement field. And once acknowledgement is received, master will continuously, either master will transmit a data in the form of byte by byte, or a master will receive a data byte by byte. So in both way it is possible, and every data transmission will have an acknowledgement. So whether data transmitted from the master to slave or slave to master, in both way we will get acknowledgement either from master to slave or slave to master. Okay, after communication, after completing your data transmission, master has to sign a stop condition. Here, whatever you are saying, finally, the master has to sign stop condition to indicate it is going to end the communication by sending logic 1 or active high signal. To end the communication, we will send logic high or nothing but logic 1 to end the communication. So this is the frame of your I2C. I hope this is also clear, and this is also important as well. Yeah. So one of the interview question you can expect in the interview is how do you generate start and stop condition? How I2C will generate start and stop condition? So this is also one of the important question you will get in the interview. The start condition, very simple. I already told you the start condition will be generated by sending logical 1 and stop condition will be generated by sending logical 1. So, but when it has to generate, that is the question here. Okay, 0, sending 0 and sending 1, understand, we can understand start and stop condition, but in which situation? That is the question here. So the start condition will be generated by sending logical low before SCL clock goes to low. That means at this position, you can see here. So first data line should go low and later the clock will go low. This is the start condition. So there is a exact timing is there. So that timing, it is going to generate the stop condition. So this is very important. So first a data line should go, then the clock line should go to low. This is for start condition. Similar to this stop condition, the same thing again. First clock should go high, later the data should go low, go to high. So in the case of start condition, first data should go low, later clock should go low. And in case of stop condition, first SCL should go high, and next the data line should go high. So in this way we can manually, we can also generate start and stop condition. This is a very important thing with respect to the I2C. Okay, so now let us move to the next topic, arbitration. So I2C, I told you already, I2C will support varieties of features. In out of that there is a one feature that is called as an arbitration. What is an arbitration? Arbitration means, I already told that we can use multiple masters in the communication. In I2C communication, it is possible to have multiple slaves and multiple masters, right? So whenever multiple masters you are using and multiple masters are enabling communication at the same time, then how I2C will behave? That is the point here. Arbitration means whenever multiple masters are initiating the communication, in that time how I2C will behave. So that is the point here. So I already told. So in I2C communication, arbitration is used to resolve the conflict that occur when two or more devices attempt to transmit a data at the same time. So try to understand here. So arbitration is a process used to avoid the conflict whenever more than one device or more than one master trying to initiate the communication. And arbitration also ensures that only one master will be controlled your I2C bus without any errors. So this process is called as arbitration. Okay. So I hope you are understood, right? So let us understand with the process and with one example. So how the I2C works. Okay, so try to understand here how I2C works or arbitration, how arbitration works in I2C. Arbitration will come into picture only whenever you're going to we're going to start communication from the multiple devices. So whenever you're generating simultaneous start conditions from the different masters. So once this is done, so I2C arbitration will be entered into the picture. And in the arbitration process, bit by bit will be compared. And if there is a mismatch, the mismatched master will be exit from the arbitration process. And if there is a match condition, then that is called as a winner, and winner will continue to the in the communication. Loser will go out of the arbitration process. So this is what 4 to 5 steps. Let us see with respect to the diagram here, bit diagram. Arbitration process will always start from the MSB side. Do remember, this is also one of the interesting thing. Always arbitration process will start from the MSB side. Okay. Assume we have three masters here. So we have master 1, we have master 2, and we have master 3. Let us assume we have three masters, master 1, 2, and 3, and all three will start the communication. Let us assume that all three will start the communication at a time. If all three starts the communication, to which master we have to allocate I2C bus? So that is done by arbitration. So in that situation, the I2C bus will compare the bits of your master. So always it will compare with the bits. Okay. So which bit? That is a slave address bit. Master 1 sends some slave address. Master 2 also will send some slave address. Master 3 also will send some slave address. So I2C bus will compare all three bits of your master 3. Here you can see all three masters are compared here. 1, 1, 1. Nothing. All are same. There is no difference, right? In the next bit you see, in the next bit also 1, 1, 1. There is no difference. But when you compare the same thing with the next three bits, here you can see 0, 0, and 1. Okay, so here there is a difference. That means what here it will happen is in our embedded communication, 0 is considered as dominant and 1 is considered as recessive. Recessive means low priority and 0 means dominant, higher priority. So in this scenario, master 3 is transmitting 1, master 1 and 2 both are transmitting 0, 0. Master 1 and 2 will be allowed for next comparison. Master 3 will be out of arbitration process, and I can say that master 3 will be losing the arbitration here. Okay, so master 3 will be out of arbitration, and still master 1 and 2 will be continuing the arbitration. The next bit, if you see, master 1 is transmitting 1 and master 2 is transmitting 0. That is why in master 1 is, since master 1 is transmitting 1 here, master 2 is transmitting 0. So this is a dominant over your master 1, and master 1 will lose the arbitration, master 2 will win the arbitration. Finally, the I2C bus will be allocated to master 2, and master 2 will continue with the communication. Master 1 will lose and master 3 also will lose. So this is called as I2C arbitration process. This is also one of the interview question you should remember. Okay, I hope this is clear. One more important thing with respect to I2C, this is also one of the interview question called as clock stretching. What do you mean by clock stretching? So when you interface, when I2C is interfaced with the devices like LCD or any display devices which are low speed devices, whenever your I2C is interfaced with a slow communication devices, sometimes the slow communication devices may not match with respect to the speed of your I2C master. Sometimes I2C speed will not be matched with the master. In that situation, I2C slaves are allowed to stretch the clock line low to match the speed, or to slow down the speed of communication. This process is called as clock stretching. So let us see with respect to the example, then I will come up with the explanation again. So here you can see I have two use cases here. One is before clock stretching and one is after clock stretching. So what do you mean by this before and after? So in the before clock stretching, you can see I have 8 bits of data, and this is SCL and this is SDA. So I have 8 bits of data, and 8 bits of data will be transmitted your SDA line. Bit number 1, 2, 3 up to 8 bit it will transmit. And finally in the 9th clock pulse, your slave will give an acknowledgement. At this point, the slave will give an acknowledgement. So this is a regular routine that is called as a regular before clock switching. But let us assume slave is operating at slave operates around 90 slow. Let us assume slave is operating at low speed. In that situation, uh, here you can see up to 8 bits it will receive data or it will transmit data, but in the ninth bit it's supposed to give an acknowledgement, no? So before going to ninth bit, your clock will be pulled low. The slave is going to slave pulls SCL line low because slave is operating at lesser speed. So because slave is operating at lesser speed, slave will pull clock line low, and later it is going to release. So this process is called as clock stretching. Slave will pull clock line low, and that clock is called as clock stretching. Okay, so this is because I already told, because of low communication, low speed communication. So now let us see here explanation what we kept. In the I2C master and slave communication process, I2C, the SCL clock on the bus always generated by the controlled by the master. That means I2C speed, I2C clock speed, everything will be generated by the master. But what will happen in a real time? But the slave cannot match the speed. This is what I told. Sometimes the slaves cannot match the speed of your master. In this scenario, I2C protocol stipulates that slave can pull down SCL clock line low. So that means this is what here it is happening. Since my slave is operating at lower speed, the slave can pull SCL line low for a short duration of time. And during this, the data transmission will get suspended. Here you can see I have highlighted here. During this period of time, the data will not transmit, and data transmission will be suspended. And this process is called as clock stretching. I hope this is clear, and this is also one of the interview topic. In the most of the interview, you will get the question, what do you mean by clock stretching? So what are the I2C operating modes? Very simple modes are there, very straightforward. In I2C, we can configure I2C in 4 different operating modes. I2C as a master transmission mode. In the master transmission mode, master will transmit data to slave. Then master receive mode. Master receive mode means master will receive the data from the slave transmitter. Slave receiver mode. That means microcontroller can behave as a slave as well, and that can also receive the data. And finally, the last one is slave transmitter mode. The controller can also behave like a slave, and that can also transmit the data. So these are all 4 different modes, and very simple to understand. So what are the advantages of I2C protocol? So this is very important. What are the advantages of I2C protocol? The first and foremost important thing with respect to I2C is we will use only 2 lines. We are going to use only 2 lines to communicate, fewer wires, and it's very simple. We are going to use only 2 lines, SDA and SCL. This is a very important thing. And multiple master and multiple slave. So using 2 lines, we can connect multiple slaves and multiple masters. That is the second advantage of your I2C protocol. Third advantage is address-based communication. I already told you I2C will support 2 types of addressing mechanisms. One is 7-bit addressing and one is 10-bit addressing. This is also one of the advantage. Error handling mechanism. There is no specific error handling mechanism in I2C, but there is something called as acknowledgement and no acknowledgement. That means if the successful transmission happened, then that is called as an acknowledgement, and when there is no successful transmission happen, then that is called as no acknowledgement. So in I2C we'll have 2 types, acknowledgement and acknowledgement. So with the help of this we can say that whether data transmitted properly or not. Then clock stretching, just now I have explained you. The clock stretching will allow the slave to pull SCL line low to match the speed of your I2C master. That is one big advantage. Speed flexibility. That means I2C, I already told, standard I2C speed is 100 kilobits per second and 400 kilobits per second. And we have high speed and ultra high speed mode. In I2C, we have standard speed, high speed and ultra high speed mode. In high speed and ultra high speed, 1 Mbps and 3.5 Mbps also we can go. And wide adoption in the sense most of the since the I2C is very popular and most of the microcontrollers are using this I2C concept inside the I2C protocol inside the microcontroller. So if you take any microcontroller, definitely there will be an I2C inside. And very flexible. And if you know the concept, you can develop code to any I2C device. These are all the advantages of your I2C. In spite of that, there are some disadvantages also there. I told you low speed. So when you compare with the SPI and CAN protocol, I2C is a low speed communication protocol, 100 to 400 as a normal speed. The second important disadvantage is limited distance. Limited distance means I already told, like within the board, intra-board communication less than 50 or 1 meter or less than 50 centimeter, you can say. So since we're using here arbitration process, because whenever you're using multiple slaves, there might be possibility of address conflict. So that is one more drawback. So it is also possible with the multiple slaves when you're using. So there might be possibility of address conflict. And because of bus arbitration, this may also create some disadvantage in the I2C. Because of arbitration process, it is again creating conflicts in the master. So because of clock stretching is an advantage and disadvantage both. So because of clock stretching, your speed will go low again. If you design 100 kbps, because of slave it might be reduced to 90 kbps. So because of clock stretching, the speed may also reduce. And we require pull-up resistors. If you see the first or second slide, we are using pull-up resistors, right? So we require pull-up resistors here. Data overhead. So you can transmit in one single time, you can transmit only 1 byte. If you have 100 bytes, you have to continuously transmit 100 different bytes. It is not possible to transmit more than 1 byte in one single shot. So we have to continuously transmit one, then second, then third, like that. And basically it is a half duplex. This is a very big disadvantage of I2C protocol. It is a half duplex communication. So it is not a full duplex like our SPA protocol, but it is half duplex. One can transmit only one at a time. And there is no any error checking mechanism. There is no any checksum. There is no any error checking mechanism in the I2C protocol. So these are all the disadvantages of your I2C protocol. I hope I hope this video is clear to all. So I try to get important informations of I2C here. So I hope this video is clear to all. With this, I want to end my video here. Please like this video and subscribe to my YouTube channel and gain the knowledge of embedded system.